Welcome to the Insight podcast. Joining me on the show today is Lluís Quintana-Murci. Lluís is professor at the Collège de France in Paris, where he holds the chair of Human Genomics and Evolution. He also directs the Human Evolutionary Genetics Unit at the Institut Pasteur. I talked to him about the story of Homo sapiens' journey out of Africa, what the study of genetics can teach us about our history, how mixing with Neanderthals and Denisovans helped us adapt and survive, what this means for a future of personalised nutrition and precision medicine, and much more. Right, before we start, I have a small favour to ask. If you haven't already, please hit the follow button wherever you're tuning into the episode. And if you've been listening to the show for a while, I'd really appreciate it if you rated the show too. This will help more listeners discover the podcast and insights from all of my amazing guests. Thank you. Okay, now for my conversation with Lluís Quintana-Murci. Enjoy. But my first question to you is, if you could have dinner with any one of our ancestors, Homo sapiens, Neanderthals, who would you have dinner with and why?
Oh, that's a very difficult one. But I think I would have dinner with a Neanderthal and asking him what happened that when humans, modern humans, Homo sapiens, arrived to Europe and Asia, they vanished. Were sapiens mean to them? Were very invasive species? I would be very curious to have their thoughts about it.
Interesting, yeah, their perspective. Because, and I suppose we'll come to this in the conversation, because we now know that there was some mixing. There was admixing. Is that the term? Amixing, admixing?
Yeah, they admix it. That's called admixture, basically,
Right.
in our jargon, right? But it just means that when two populations mix to each other, yeah.
Yeah, but most of us, I think, have the conception that, that we went over, and when Homo sapiens arrived, we wiped them out. But we'll get to that. Why don't we go a few steps earlier, which is the story of Homo sapiens and our journey out from Africa. So what do we know about that?
Well, actually, in the last decade in particular, we have learned a lot about the origins, migrations, admixture, and adaptation of Homo sapiens. If we put together all what we know in terms of anthropology, archaeology, but mainly genetics, that's the point of my book. And even more than genetics, the possibility of sequencing also DNA, our genomes, from ancient remains. What we know is that Homo sapiens originated around 200,000, 300,000 years ago, for sure in Africa. We still don't know where in Africa, in particular, in terms of geographic location. What we do know very, very surely is that our ancestors left Africa around 60,000 years ago to very quickly people Europe, Asia, Australia, and near Oceania around 50,000 years ago. Then, much later, a group of people from Siberia crossed the Beringian Strait to people around 20,000 years ago for the first time the Americas. And then much, much later, some regions of the planet were people like remote Oceania, let's say Polynesia today. And Polynesia, what we call the Polynesian Triangle, that is in the north delimited by Hawaii, in the southwest by Aotearoa, which is New Zealand, and in the southeast, Rapa Nui, which is Eastern Island. This triangle was people just over the last 1,000 years. So can you imagine that people in Europe were building cathedrals or starting to, and there were no humans yet to that part of the world. So the human journey started basically 300,000 years ago within Africa, and then over the last 60,000 years has been spreading all around the planet.
And do we have any idea of why they would have done that? Is it just basically to look for resources? Is it becoming overpopulated in certain areas, or there are other factors as well as of why you would leave and venture out to some quite, I suppose, inhospitable places at times, wasn't it? Maybe.
I think there can be reasons like climate changes, volcano explosions that triggered, for example, how do you say, a lack of food resources, so famine. I think there's many different reasons why humans migrated during their history. There's another reason that is maybe less basic for our understanding, but that really characterize us as species, and is curiosity. For example, let's go to the Pacific again. That is a region of the world that fascinates me. Why some populations were embarking in boats and were going through miles and miles of sea that they didn't know where they were going, right? So I think curiosity, and that's the kind of the romantic way of seeing is curiosity. The less romantic way of seeing it is invasion. Humans are an invasive species. We are everywhere in the planet, and we've got to be living in places that are very inhospitable. The Arctic, the rainforest, living at 3,000 meters above the sea level in Tibet, where there is oxygen concentrations that impose a huge stress on your body. Why? We have to be everywhere. We can talk about that if you want.
Yeah, well, we'll come to that, won't we? And the adaptations that have come about from living, or that enabled us to live in those environments. But what you say about the curiosity, that's so interesting. Maybe the same reason that we're wanting to get to Mars and explore outer space, this curiosity that was around 60,000 years ago and is still encoded inside us, perhaps. Is that something that you feel yourself? Is that your curiosity to get into this subject? Like, I'm wondering how someone like yourselves comes to be a geneticist and interested in peoples and how they lived so long ago.
I think, actually, well, I grew up in Mallorca, so in the sea. So the sea and was something very important for me. And I used to see a lot of documentaries. Probably my mother put me in front of the TV, but at least in front of Jacques Cousteau documentaries. So I got this kind of passion for sea mammals. I wanted to study whales, dolphins. And actually, in the end, I didn't do anything about that. But to answer more straightforward your question, curiosity is part of me. I remember being a teenager and going with my scooter to the airport to see foreigners. I'm talking about the 80s in Mallorca, right? It's not like today that everything is very easy for us. But I remember I was fascinated by these people speaking different languages and hearing different languages, diversity, difference. Culturally and biologically, despite I was not conscious of that at the time, even of these terms, I probably didn't even know them. But it's something that always attracted me. I was fascinated by people that were different from me. Yeah,
the stories of people and now you're looking at that at an even broader scale. Next question. Before we come to that, could you just move your mic slightly away? There's a bit of a popping sound sometimes. Yeah, that should be absolutely fine. Like down or a bit away, it should be absolutely fine from now on. So where does genetics come into this? Because I guess most people have a sense of archaeological evidence and how that can give us clues about that journey that we talked about of Homo sapiens out from Africa and how we can see evidence of them around the world. At a basic level, where does genetics come in, and what can it tell us about how our ancestors lived a long time ago, and also maybe what can't it tell us as well about how they lived?
Sure. I mean, genetics can bring some answers that archaeology and anthropology cannot. I will give you two examples. The first is we know that humans reached Europe around 45,000 years ago. They were hunter gatherers. And we know that around 10,000 years ago, agriculture emerged in the Near East and then came to Europe, agriculture. We know that based on archaeology, and spread over Europe in a few thousand years ago. So from the Near East to what's today the UK and Ireland were the last parts that where agriculture arrived. But archaeology cannot tell you if that was a cultural diffusion, meaning agriculture was being taught from one community to the other, and the culture, the tools were spread, or if it was what's called in jargon endemic diffusion, that means movements of population that were bringing the technology, but also the people. So it was just the transmission of a technology, like the transmission of a language, like during the Roman Empire and Latin, or was movements of people that were bringing a new technology. And it's there that genetics can tell you something. Because in the second case, where there is movements of people, today you should see these movements of genes, right? And it's where genetics has beautifully shown that there was real movements of Anatolian farmers starting around 8,000 years ago that were moving into Europe step by step and admixing with the local populations of hunter-gatherers.
Right. And then displacing or mixing. What's the story there? Because this might be, it was news to me, certainly, to find out that actually, I mean, is it right to say we've all got a little bit of Neanderthal in us? Is it 1% to 3% was the percentage?
This is very true. But let me answer first to your question. That is it displacement or a movement?
Right.
Here again, genetics can tell you answers that are very sharp and very solid. Why? Because when two populations meet, there's three scenarios. One is that they just stay neighbors and they do not mix. The other scenario is that one population replaces the other, usually as a result of conflict. The other scenario, the third one, is that they admix. So genetics, both at the global scale, has shown that in most cases, let's be positive for once, when two populations encounter, there is admixture. All of us, we are admixed to different extents. Entire continents, such as Central and South America, most populations today are admixed between the Native American component, who admixed with Europeans that came during the colonial period, and that admixed to different extents to African ancestral people that came during the slave trade. Then that admixture occurred for good or bad reasons, that's another thing. I'm just telling you that we are admixed to different extents. Even us, apparently of homogeneous European, British origin in your case, I guess. Even us, that we look kind of similar, we are at least the product of 4 different genetic components. As you mentioned, you and me, as all people outside Africa, we have around 2% in our DNA of Neanderthal fragments, DNA, plus we are the result of the first hunter-gatherers that came to Europe from Africa around 45,000 years ago, that had mixed with farmers coming from Anatolia, present-day Turkey, bringing farming to Europe, who had mixed it again around 4,000 years ago, at the end of the Bronze Age, with population coming from the eastern steppes that brought most likely Indo-European languages. So we Europeans, we are the result of these 4 different genetic components.
Wow, a lot more. There's a lot more to it than you first realize, isn't there? Okay, I'm trying to think where then the next question then. Why would this mixing have occurred? I mean, I guess we have maybe a more bloody kind of and violent view of the past, that it would be this conquering and wiping out populations. But actually, we're saying there is this mix which must have been based on, trust and things, and not quite as violent as we might have imagined. But how is it that there could have been this mixture if, when you picture Neanderthal, for example, the prominent brow and things like that, is that all just very kind of pop culture? Is that very basic understanding? I'm not sure if I've worded that question very well, but looking at what would seem like a completely different species, like how could it be that we would ever mix with someone that would look so different and be so different from us? Does that make sense?
Well, the problem is that I don't have an answer to that.
Right. Okay.
Right? I think, however, I mean, there has been, what genetics can tell you is that there has been a mixture, obviously, between Homo sapiens and Neanderthals, between different populations of Homo sapiens. How that mixture was occurred, actually, and it was forced mixture. Certainly, yes, in some cases, even relatively recently. Obviously, European colonialists in the Americas, there were rapes
Right.
with Native Americans and with African slaves. Look also the massive disaster of Native American populations everywhere in America, and I would say even more strongly in North America. So, yeah, I don't know if I'm answering your question, but I think I'm just a geneticist, so I can tell you what's the legacy of all that. Then how we went through that. That's much more difficult for me, in any case, to comment on that.
No, of course, you can just see what you can see, and maybe a bit of a naive question from me, and thinking that it was less violent, but of course there were going to be some violent and horrible aspects as well. What about, is it Denisovans? I can't say it.
Denisovans.
Denisovans. There we go. This is a story that I didn't know about. Tell me.
That's a very cool story that, again, it's very important because just genetics could define a new lineage, a new human lineage that today is extinct. I tend to avoid the word species, as you will see, because as long as part of their genetics is in us, that showed that we were not different species, because in theory, two different species doesn't give rise to offspring that is fertile, the fact that you and me, we have 2% of our genomes that are of Neanderthal ancestry, show that Neanderthals and modern humans, Homo sapiens, were not a different species. So I tend to say human lineages. So the Denisovan lineage is very interesting because just thanks to genetics, it was discovered. Everything started in a cave in Siberia that is called the Denisova cave, where they found a little piece of a finger, a phalange. How do you say in English that?
I think that's right. Yeah.
A phalange. And they thought that was on the basis of a little thing like that. They thought that was from a Neanderthal because there were other remains of Neanderthal in that cave. So the group of David Reich and Svante Pääbo, so Harvard, Leipzig in Germany, Harvard in Boston, they sequence that and they compare it, the sequence of that, the DNA extracted from that little finger from a Neanderthal sequence. And they say, oh, that's not a Neanderthal. If we compare the two sequences, we show that the two sequences diverge from each other around 500,000 years ago. So, thanks to genetics, because on the basis of just this, a little finger, you cannot say this is a Neanderthal or whatever. So, they discover a new lineage, a new human lineage that got extinct. And now, by comparing that genome of the Denisovan, the name was given because of the cave where it was discovered, we know that the East Asians populations, they have around 0.1% of their genomes, present-day East Asians, that come from Denisovans, and present-day people from near Oceania, Papua New Guinea, the Solomon Islands, the Vanuatu archipelago, can have up to 3% of their genomes that are of Denisovan ancestry.
Right. And do we know much about their appearance, their capacity, their brain size, things like that? Because we know a little more about Neanderthals, as I understand it, which I want to come back to. But yeah, do we know anything about Denisovans?
Well, we don't know almost nothing about them. There's just one genome there. On the contrary, what we know, and it's something that I explain carefully in the book, and actually because it's something that we did in my lab here in Pasteur, Institut Pasteur in Paris, is why has been important the contribution of Denisovan to present-day people. This 2-3% of Denisovan DNA present in Pacific Islanders, we've shown that has been very important for these populations to adapt to pathogens in particular, to better survive to pathogens and to infectious diseases.
Right. Can you tell me a bit more about that then? Because I think that's the other really key and interesting point, isn't it? That this mixture has aided our evolution and our adaptation to environments and resources and pathogens, as you said. So what does that mean?
Listen, that means genetics, as well as archaeology and anthropology, as we know, has helped us to delineate migrations and the chronology of these migrations at the global scale. However, we have to keep in mind that humans, when they left Africa around 60,000 years ago, they have to adapt to different climates. They have to adapt to cold, for example. They have to adapt to different nutritional resources, and they have to adapt to different pathogens. So imagine a population that comes from Africa and gets into Europe, enter Europe. And in that case, sapiens found another population of Neanderthals that were living in Europe for at least 300,000 of years. So by definitions, the Neanderthals were adapted to the European cold and to the European pathogens. So one thing that my lab has been very, very much interested is something that is called adaptive introgression. What does it mean, these kind of fancy words? Basically, it means, was the admixture between sapiens and Neanderthals advantageous for sapiens? Because since Neanderthals were adapted to the environment, what we wanted to understand us was, during this admixture, did sapiens acquire from Neanderthals mutations that allowed sapiens to better resist cold and to better resist pathogens? And what my lab in particular has shown is that this admixture between early Europeans and Neanderthals was particularly advantageous to survive infectious diseases, in particular viral infectious diseases, and in particular infectious diseases that were caused by RNA viruses like influenza virus and even SARS-CoV-2.
Right. Wow. Because, I mean, I just think for many of us, we think that we would have journeyed into these colder climates, higher altitudes, but the adaptation would have been in our, not genetic, but in the way that we dressed and made clothes and shelters and things like that. So I guess that was my understanding, and maybe it would have been other people's understandings. Oh no, it was our ingenious and our creativity that enabled us to do that. But actually, there's this whole other story. It's fascinating.
But you're absolutely right. I mean,
Also,
I'm a
that as well.
geneticist, of course. I'm a geneticist, and cultural and technological adaptation has been key for human survival. The invention of clothes to protect against cold, the introduction of antibiotics and vaccines, this is just in the last 100 years, to fight infectious diseases. But genetics and genomics, which is the word to make it more general, has provided emblematic cases that our species can biologically, genetically in particular, adapt to cold, adapt to digest milk in adulthood, genetic adaptation to live in conditions where oxygen is there's much less concentrations of oxygen, like living in high altitude in Tibet, in the highlands of Ethiopia, in the Andes, in South America. Genetics has provided even remarkable examples that humans can adapt to a lifestyle that is based on diving to live, right? Diving and fishing and spending minutes and minutes underwater, making that you will have a bigger spleen, and this will allow you to be without oxygen for much longer than you and me, right?
Yeah, I've seen in one of the. Do you know David Attenborough? Have you heard of David Attenborough? Our famous.
Cannot hear you now.
Oh, can you hear me now? Hello?
Now, yes, yeah.
Great. Have you heard of David Attenborough? Do you know our nature commentator? Yeah. I remember one of his programs, I think he featured those divers, and like you said, they're going right down to depths and holding their breath for so long. Really interesting. You also mentioned that there might have been some disadvantages as well. Is that right?
Absolutely, because when we talk about biological adaptation and genetic adaptation, we might have adapted to things in the past, and the environment change, and the exposure and our lifestyle change also. So an adaptation that was good for our survival 10,000 years ago might not necessarily keep on being advantageous today. Let me give you an example. We have been 99% of our history of species, we have been living in famine with very few nutritional resources. So say that we have that mutations that allow us, so variants in our DNA, that allow us that from very few food maximize energy intake were selected. Great. This allows us to survive famine. But when you dramatically change our diet and you introduce Western wealthy diets, the same mutations that have allowed us for thousands of years to survive famine, today they can predispose us to obesity.
Mm.
Another example, for thousands of years, natural selection has selected mutations that allow us to have a very reactive immune response, a very strong immune response to fight pathogens. But the same mutations that made our ancestors survivors against the Black Death, tuberculosis, leprosy, many infectious diseases, the same mutations today can be responsible for autoimmunity, inflammation, and allergies because the environment has changed. And even culturally, we introduce antibiotics and vaccines. So, in some regions of the world, we live much longer, right? So, but the environment changed, and let's meet in 3, 4, 5,000 years ago, and let's talk how the introduction of antibiotics or vaccines change the pace of natural selection.
Right. And so then are you looking into the future then by that? By that, do you mean like what might happen now that has the damage been done at this point? Could we be looking out in a few thousand years and thinking, oh gosh?
Oh, I wouldn't talk about damage for many things. I would certainly talk about damage when it comes to deforestation, exploitation of natural habitats. That's damage for sure. However, the introduction of antibiotics and vaccines has not been a damage. Let let allowed me to give you a very precise example that, moreover, it's in the UK. In the end of the 19th century, in the UK, just 38% of the population reached the age of 40. This is yesterday from an evolutionary point of view. Liverpool, the end of the 19th century, 38% of the population only reached the age of 40. Today, 98% of the UK population reach the age of 40. This is because all what happened in the end of the 19th century and the beginning of the 20th century in terms of hygiene improvements, the introduction of antibiotics and vaccines. So, of course, this might have changed in Western Europe, is what we are talking now, the pace at which natural selection acts. But I do prefer that most of our friends and
Yes.
family lives longer than what used to be the 19th century.
Yeah, the countless lives that have been saved by vaccines, and it feels like every few weeks or months we see a new story about a disease that has been eradicated because of the introduction of vaccines, and like countries around the world where just the rates of dropping and dropping and dropping. And of course, that is a fantastic thing. Everything you've said so far, what does it mean for me and you, and maybe the choices that we make on an individual level? Can it tell us anything about that? Where we might choose to live, how we might choose to eat, that kind of thing. Does it have any role in actually affecting us day to day?
Yes, that's an incredibly difficult and super broad question.
Sorry.
No, because I think it's an extremely interesting question. But let me answer you a bit step by step. Why does it matter to care about our origins? If we admix it or not with Neanderthals, if you're a bit admixed between a bit of Neanderthal, the Cheddar Man, a bit of the Vikings, and a bit of the Celts, for example. So why do we care about that? Oh, we care because don't forget that you and me were nothing else than the descendants of the survivors. If we are here speaking today, it's because our ancestors survived. And by studying our genomes, we can kind of have a grasp of this genetic resilience.
Mm.
By studying which are the genes that allow our ancestors to survive infectious disease, to survive famines, we can pinpoint genes that today make that you and me may be different in terms of susceptibility to COVID-19. But we are not a gene factory. We are not just the product of our genes. We can have different ages, we can have different biological sexes, we can eat differently, which make that our microbiome, meaning all these thousands of bacteria that live in our skin or in our gut, will be slightly different. But understanding uh, the past will first make us understand much better who we are today.
Mm.
And by understanding who we are today, in terms of genes, but also in terms of being a man, being a woman, being younger, being older, what we eat, our lifestyle, our past, all this will set the basis of precision medicine. That is how our genetics, together with our lifestyle, make that you are more susceptible than me to COVID-19, but I'm more susceptible than you to Crohn's disease, right?
And how far away are we from that personalized precision medicine?
We're not very far. I mean, not
Wow.
very far. I mean, in the next 10, 15 years, there's still, at a smaller scale, precision medicine approaches for some therapeutic treatment,
Mm.
knowing if that you have this and this and this genetic profile on these given genes that are associated with the metabolism of some drugs, you are going to be given this drug and not this other drug, because depending on your genetic profile, you will have less secondary effects, and this given drug will be more efficient for you.
Wow. And do you feel like you're a part of that story as well? Do you feel like that you are working towards that? And that must be incredible to think that you might be playing a hand in helping save lives.
Well, at a very small scale, and I'm in the book. I'm not talking about. I'm not talking only about what my lab and myself has done.
Your
I'm
colleagues as
talking
well.
about the last 20 years of the community
Yeah.
of human genomics. And basically, what the book, I think, is very clear and can be summarized in: let's understand who we are, where do we come from in terms of genetics. This will tell us who we are today in terms of admixture, and let's use all this information of our genetic makeup today, together with our lifestyle, to better understand where are we going. So precision medicine. Yes, I have participated, my lab, at a smaller scale, that is to better understand the genetic makeup of some Central African populations, of some Pacific populations, how Neanderthal and Denisovan heritage in present day human populations has influenced our immune response to pathogens. This is my little contribution to this huge field.
Have you thought about the darker side of what this might bring? How, I don't know, this might create wider gaps in society if there's more well-off people that can access this precision medicine and poorer people that can't. Other instances of I mean, people talk about playing God, don't they? And and manipulating our genetics, and can we do things in what is it, in utero, during the pregnancy and things, and making alterations there? You can tell I don't know much about this. I've just read and
No,
heard little
th-
bits, but I'm just curious.
of course, there's 1,000 questions in your question. But can this exacerbate health inequalities? Well, in principle, no. If we are conscious of already the ethical inequalities of things, and we do all what we can to how do you say, to compensate this. I give you a simple example. Even in my field, that is human genetics, there's a huge bias. That is, 78% of all genetic studies in humans are conducted on individuals of European ancestry. And individuals of European ancestry just represent 16% of the people of the planet. So there's a huge inequality already. But this does not preclude that we cannot work on this. Actually, we have to work on that, but we have to work on non-European ancestry populations also, right? I mean, uh, on the one hand, but your question is extremely complicated because you say, yeah, but genetic studies could also make that in utero things. Well, that's why we have laws.
Mm.
And geneticists, we have to do our job to understand uh, who we are and to try to improve the health of humans, not only the health of rich European ancestry humans in Western Europe, North America, and Australia, for example. And that's why, as I explain on my book, and as many labs we are working on that, for example, my personal research is in Polynesia, right? So at my small scale, I am contributing. To do human genetics and medically related research in populations of non-European ancestry. But then other people, not me, people that are politicians and lawyers, have to keep on working very carefully in protecting all this.
Mm.
And they are.
Good. That's what it's all about. And it feels like there's some parallels with AI and algorithms and data. We're making these huge advances, and we also need to be very aware of that. And like you said, what are the policies and the laws that have been put in place to protect people? Because like anything, any good technology, of course, there's some bad actors and good actors. What about on a global scale as well? Kind of to round this all off, I guess, to round the conversation off, is there a way to look at this on a bigger picture in terms of migration and climate change? If people were more aware of this, of where we came from and our story, would it mean, I don't know, would it have implications in our understanding of race and gender and all this and all these different things? Would it make everyone just a bit more understanding? But also, going back to what I said at the start, would it could it influence migration and climate change, that kind of thing as well? Another big question to
Well,
throw at you.
that's super difficult question. The only thing I can tell you is that as a species, migration, admixing, and adaptation has been a huge part of our past. And I don't see any reason why should not keep on being an important and a positive part of our life as humans. I mean, uh, understanding and other cultures uh, and embracing other cultures do not mean, does not should not mean to replace your own culture, right? And this is what many people is afraid. But 1+1 can make 3. And this is my way of saying it. And the only thing I can tell you from my work in terms of genetics is that admixture has been uh, a vehicle and an accelerator of human adaptation in general.
Beautiful, beautiful to hear. Right, Lluís, thank you so much for your time this evening.
Thanks to you. Was a pleasure.
Good. I hope, it was obviously I have a basic understanding of something that you have an incredible understanding of, but I hope I know it might have kind of skimmed the surface, but I think it's so cool to hear about our story and those bits that maybe people don't understand and they might be hearing it for the first time. And I think that's really, really cool and exciting. Now, you mentioned your book, which is out in England in I think 3 days, isn't it? On Thursday, on
right.
the 31st. So where can people tell us a little bit about the title and where people can get it as well?
Well, Human Peoples is the title of the book, and people can get it in Amazon or in the libraries, and it's 25 years of work in the field, and summarizes all what we have been discussing today, understanding who we are, understanding our origins in Africa, our travels through the world, our adaptations to climate, to pathogens, to food, our admixture with Neanderthals, with Denisovans. And then at some point, the book says, well, and what we are doing with all this information. So all this genetic information that is engraved today in our genes, as I explain in the book, is extremely useful to make us understand where are we going in terms of future survival, in terms of precision medicine, and in terms of health. And this is a book I couldn't have written a few years ago, because the last 10 years in particular have been such a revolution in the field of human genetics, that, and all this is explained in the book for a general audience, I hope. Of course, there's technicalities, but I wrote it in a way that I wanted both scientists in my field to learn something, but also people that are educated and interested in the field may learn many new things.
Mm. And are you hopeful? Are you hopeful about the future, knowing all of this? Because we can get quite oblique, can't we? If you watch the news or scroll through social media, it can be quite bleak, can't it?
In this moment, that's not the right moment to ask this question, but it would take a step back. Yeah, I'm hopeful. I think we have learned from the errors in the past. I want to think that there's still, well, I don't know. I want to think that in the very end, we have and we want to survive. And to survive, the only thing we can do is to be more friends with each other. That sounds super cheesy, but in the very end is our only way to survive.
No, it might be cheesy, but it rings true. It rings true. We're all about that. I love it. More love and friendship. This is what we need. Right. I'm going to finish off with 3 quick fire questions I ask every guest, if that's okay.
Sure.
So the first one is, what's one lesson you wish you'd have been taught when you were a child?
Be more confident in yourself. And dream. You will be great. Dream big.
Nice. Next one. Is there a habit that you've added to your life, or maybe a habit that you've got rid of that's helping you feel happier and healthier?
I run 3-4 times a week now for a few years. This makes me feel mentally healthier and physically healthier also.
Love it. And the last one, if you could give everyone in the world one book, which book would you give them?
Wow. That's a very difficult one. Oh, let me think about. Can I say I have no idea?
Of course. Of course. We can go with the last book that you read. I mean, do you ever read fiction, or are you purely academic? Is it only scientific papers you're reading?
No, of course. No. At home and to relax. I don't read novels. I saw a lot of TV series and movies, but to read, I read history. I'm passionate about history, but I don't read science. Never at home.
Oh, really? So, like, is that ancient history or more recent? Are you a Yuval Harari fan? Are you something like that, or?
No, that's even too serious for me.
Oh, okay.
No, I read history like I can read a biography like. For example, I read the biography of a woman that fascinated me that is called Marie Bonaparte. She was a French heiress in the beginning of the 20th century, very rich, and princess of Denmark and Greece by marriage. But what fascinated me of her is that she was a disciple and a patron of Sigmund Freud, the psychoanalyst, and she used her wealth and influence to help Freud and his family and many other Jews to escape Nazi-occupied Austria. And also, what fascinated me of this woman is that she was speaking publicly and wrote books about the quest of pleasure and even of sexual pleasure, right? And that was absolutely incredible for a woman in the 1930s and 1940s, not to mention for a woman of a royal family. And I found by completely incidentally this book, and I found her biography fascinating.
It's a good one. I've never heard of her, so I'll go and investigate more. Nice one. Right. Thank you again so much for your time. I'll put a link to the book to where people can buy it on Amazon in the show notes. Check it out, people. And thank you so much again. Pleasure to talk to you.
Thanks so much, Sam. It was really a pleasure. Bye-bye.